All right, but now I want to explain to you where this A naught comes from. And I want to, and that allows me then to also explain a very important concept here about quantum mechanics. 1911, by 1911, both the electron and the nucleus had been discovered, and scientists were trying very hard to understand how the electron and the nucleus hung together, and it wasn't really till 1926, when Schrodinger wrote down his wave equation, that things really began to make sense. But there were many attempts in between 1911 and 1926 to understand what was going on with the hydrogen atom. And one of those attempts was made by Niels Bohr. And, spell this backwards. I think it's N-I-E. Okay. And what Bohr said is, well, okay, I know this classical physics predicts that this electron will plummet into the nucleus in 10 to the minus 10 seconds. That is, if I take a planetary model, I put the nucleus in the center, and I give the electron a uniform circular orbit around that nucleus, well, I know classical physics tells me this won't hang together. But let me ignore that. And let me propose that there's something quantized about the hydrogen atom. And he knew that because he knew the hydrogen atom spectrum. He knew that in the hydrogen atom spectrum that light was emitted at only certain frequencies, as we saw the other day. And that gave him the idea that there's something quantized about the hydrogen atom. So he then proposed, okay, let me go and I'm going to quantize the angular momentum of that electron going around in this circular orbit. So what he did is he kind of took a classical model and he pasted some quantum mechanical ideas onto the system. All right? And when he did that, the value for R here, at which the electron was going around the nucleus, well, that value of R ended up being what we call here the Bohr radius now, this value of A naught. Okay?